Hey there, welcome back to the channel. If you're into machine learning and want to get a deeper understanding of how to make your model more powerful, today's video is for you. So we are diving into one of the most effective and popular algorithm in the world of machine learning, that is gradient boosting. So gradient boosting powers some of the top performing models in the data science competition like Kaggle, and it's a technique that's built strong predictive models by combining multiple weak learners to create a robust, accurate model. But how does it work and how we can use it in Python? First, let's break down what gradient boosting actually is. Imagine you're trying to predict something, but your model is not great. In fact, it's quite poor at this job. So gradient boosting is an assembled technique where we combine multiple weak models, typically decision tree, to form a much stronger model. And each new tree is the sequence tries to correct the mistakes made by the previous one. So in simpler terms, we boost weak models by focusing more on the areas where the previous models were wrong. And this boosting process continue, making the model more accurate with each iteration. And let's break it down step by step how gradient boosting work in detail. So first step one, the initial model, stage one, where we start by training a weak model. This is typically a decision tree, but a shallow one, which is not great at predicting. Now compute residual. Next, we calculate the residual, the difference between the predicted value and the actual target values. Third, fit a new model. Now we fit a new model to this residual, trying to predict where the previous model went wrong. Step 4, add the new model. So the new model predictions are added to the previous prediction. So we have a better overall predictions. And the final repeat of this process continues with each new model improving the prediction from the previous models. And the key is that each new model focus on the mistakes made by the previous one. So we'll write enough theory. Let's get hands-on and implement this in Python. We'll use scikit-learn to create gradient boosting model. But before we jump into it, make sure you have installed all the necessary libraries. You can install them using uh, pip, pip. Right? Let's import the necessary libraries. This I'm importing just to stop the setting with copy warning. Next, we are importing data from UCI ML repository, and this is the hard data set. So, what exactly the hard disease data set? It contains several features like age, gender, blood pressure, cholesterol level, and more. And we'll use this to predict whether a person has a healthy disease. Sorry, has the heart disease. So our target variable presence of the heart disease will be as a target variable where 1 indicate heart disease and 0 means no heart disease. So after loading the libraries, we'll do some data pre-processing. Let me install this library in the meanwhile. So in the data pre-processing, before we move to the training, we need to do some basic data processing, and this include handling the missing values, encoding categorical variables, and splitting the data set into training and testing sets. So I hope this is installed, and now we can see our data set here. I've just seen the column names here, and the next one is to check the missing values and also do the encoding for categorical variables and check the variables for the missing values. So there are 4 missing values in this column and the 2 in the target column. And just to check the shapes of both x and y, Here we are splitting the data set, and here we are doing the modeling. Next, we'll predict do a prediction using the X text and store in the Y PRD, and let's evaluate. So our basic model is giving the accuracy of 0.49. And now let's visualize the learning rate. So if I run this and let me plot, so it will take some time because there will be 100 iterations. So we are using 100 trees with a learning rate of 0.1 and maximum tree depth of 3. So this typically is starting point, but we will always tune this parameter further. And this is the learning rate of the model by, so we are plotting the training and the test error. And as you can see, actually the training error goes down as we move for the as we move in the number of the estimators. But the test errors, it's remaining flat almost at 0.49. So this model is actually overfitting the data, right? So that was we just want to show you the working of the gradient boosting. So this is the detailed walkthrough of the gradient boosting using the hard dataset. And we see how this technique can help improve the model performance by iteratively focusing on the mistakes made by the previous rig. With the proper tuning, you can achieve a great results. Cool. I hope you like this one. See you in the next.